we're going to look at this lemma. If you have a polynomial, then there exists a real number such that as long as you are far enough away from the origin, the polynomial, the modulus of the polynomial is going to be between 1/2 the coefficient of the largest degree term times z to the d, and is between 2 times the largest coefficient, or the highest degree coefficient times z to the d. And what this is saying is something that you're already familiar with. Right? In calculus, if you take the limit as x goes to infinity of 5x to the 9th, blah, 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 over 12x to the 9th, you would naturally say, oh, this is basically, as long as x is going to be big, is this. You can just ignore all the smaller degree things. Oh, so that's equal to 5/12. This is what the lemma is saying, is that as polynomials get big, you only need to look at the largest degree terms. Right? A to the d, you only need to look at this guy. But it's saying more. It's saying exactly, it's quantifying how close you're going to be. You're going to be between 1/2 this thing and 2 this thing if you look at the moduli. So I'm going to give you a brief proof, except I'm going to give you a particular proof. I'm going to prove for p of z equals, what do I have? 7z to the 9th plus 3. Right? If this is real numbers, right? If you have 7x to the 9th plus 3, that 3 is not going to make that much of a difference if z is 100. Right? 7 times 100 to the 9th plus 3, the 3 doesn't change things that much. And so the basic idea here is I'm going to rewrite this as 7z to the 9th times 1 plus 3 over 7z to the 9th. Now, as z goes to infinity, this thing is going to go to 0. But the question is, how close is it going to be to 0? So what I want, I want an m such that if z is, this m is a real number. So if z is bigger than or equal to m, let's just erase that to clean it up. As long as you're far enough away from the origin, then I'm going to want this thing to be small. I want the modulus of 1. Well, let's not even do that. Let's not even do the modulus. Let's just do 1 plus 3 over z, 7z to the 9th. I want this to be between 1 and 1 with a little bit of error. Maybe I'll put down, you can be within 1/2 of 1. So you can be, let's just write this, 1/2. You basically need 1/2 is between, this thing. And let's just change this to a modulus. Like so. To 3/2 so that they're real numbers. So I need to pick the distance big enough so that this is true. And notice if I subtract 1 from everything, I get -1/2 has to be between, or 3/7 times the modulus of the 9th has to be between 1/2 and -1/2. Or in other words, another way of saying this is that the absolute value of 3 over 7 modulus to the 9th has to be less than 1/2. Well, how big do I have to be? If I do just a little bit of algebra, I can get 3/7 has to be less than 1/2 times z to the 9th. Oh, and I can multiply both sides by 2 and get 6/7 has to be less than z to the 9th. In other words, the 9th root of 6/7, z has to be bigger than this. So I can let m be equal to the 9th root of 6/7. Now when that happens, that means that this thing is going to be between 1/2 and 1. And so if I take the modulus, this is going to be between 3/2 7z to the 9th and 1/2 7z to the 9th